Assalamualaikum and greetings to all. Okay, let's continue with example 6, where here we have an integrand z over square of x squared plus y squared. Integrate over solid G, and solid G here is bounded by the plane z equals 2. So this is a horizontal plane parallel to the xy plane, but we shift 2 units up. And here we have the surface z equals x squared plus y squared. And if you recall from from example 4 and example 5, this is a paraboloid that that opens upwards. Okay. All right. So let's sketch our paraboloid first. So this is our paraboloid z equals x squared plus y squared. Again, if you don't remember this, you just draw the traces, the view from the front, the side, and from above. So what we have is a paraboloid. So it's a combination of parabola, and then of course it can go up forever, but then we have this plane z equals 2. So let's say this is z equals 2. So here we have the horizontal plane z equals 2. Okay, so this is z equals 2 plane, and here we have the paraboloid z equals x squared plus y squared. Okay, now we're going to use cylindrical coordinate. So if we want to evaluate this by using cylindrical coordinate, we have to project our solid G onto the xy plane. So if we do that, then our projection, so if we project our solid G onto the xy plane, what you get is a circle. Okay, what you get is a circle. Now we need to figure out what are the radius of the circle. Well, the radius of the circle would be the same length here, the same length as that. Okay, so that is when these two surfaces intersect. Okay, so here we have at the bottom we have z equals x squared plus y squared, and this paraboloid here intersect with the plane z equals 2. So from here you can see that on z equals 2 plane, the circle here has the radius square root of 2. So if this length from here to there is square root of 2, then you can say that this circle and on the xy plane would have the same radius. So here we have square root of 2, and negative square root of 2. Okay, so that would be the projection. So the projection is a circle of radius square root of 2. So I'm going to sketch this separately on the xy plane. So that would be the projection of our solid G onto the xy plane, which is a circle of radius square root of 2. So another name for this is r squared equals 2, and r is square root of 2. So the equation of this is r equals square root of 2. Okay, now back to our integrand here. Since we want to use cylindrical, we cannot use x and y. So x squared plus y squared there will be replaced by r squared. So we have r squared then square root, and dv here would be dz, and then we have r dr d theta. Okay, now let's get the limit for z first. So remember, the limit for z, the upper limit for z would be the top surface, and lower limit would be the bottom surface. Okay, referring back to our solid here, if we draw a straight line parallel to the z-axis across our solid here, then you can see that the top surface would be the plane, and the bottom surface would be the paraboloid. Okay, so the top surface is governed by this equation, z equals 2, and the lower limit would be the bottom surface, which is governed by this paraboloid, but then we don't use x and y, so x squared plus y squared there will be replaced by r squared. Okay, now let's get the limits for r and theta. So for r and theta, we refer to the region r, which is on the xy plane. So here let's get the limits for theta. So for theta, we just we measure from the positive x-axis anti-clockwise direction. Now you can see that it does start at 0, because it's the whole circle, so theta is going to be from 0 to 2 pi. And the limit for r, we draw a straight line from the origin across your region, straight line, and then you can see that it starts at 0 at the origin there, and then it stops on the circle, where the circle is governed by the equation r equals square root of 2. So r is going to be from 0 to square root of 2. Okay, alright, let's integrate this. 0 to 2 pi, 0 to square root of 2, and remember we want to integrate with respect to z first. So here, if we simplify the integrand, this is just z, because here we have r and here we have r dr d theta, and r over r is 1. So oops, what happened? Okay, all right. Okay, here we go. So we just have z integrate with respect to z. Okay, missing r z here. Hang on. Okay, so we have dz, dr, d theta. Okay, so it's just z. So the integration is just z, dz, dr, d theta. Z from r squared to 2. R is from 0 to square root of 2, and theta is from 0 to 2 pi. Okay, so once you have all the limits, then it would be so much easier to evaluate this. So I'm gonna copy this to the next page. Okay, let's evaluate. Okay, integrate the inner integral first. So here we have 0 to 2 pi. 0 to square root of 2. Integrate z with respect to z will give you z squared over 2. Replace z with upper and lower limits, r squared to 2. Okay, from there we get 0 to pi, 0 square root of 2. So here we have 2 squared is 4, 4 divided by 2 is 2. And then replace z with r squared, we get r to the power 4 over 2. And now we're going to integrate this with respect to r and then theta. Okay, middle integration. Integration with respect to r, so that 2 will be 2r. And r to the power 4 over 2 will be r to the power 5 over 10. Okay, replacing r with upper and lower limits. Okay, so here we have upper limit minus the lower limit. So here we have 2 times square root of 2. And here we have square root of 2 to the power of 5 over 10, and here we have d theta. Okay, square root of 2 to the power of 5, that is really, hang on, square root of 2 to the power of 5, that would be 2 1/2, 5, so this is 2, 5 over 2, which is equal to 2, 4 over 2 times 1 over 2. So that would be 2 squared square root of 2, which is 4 square root of 2. Okay, 4 square root of 2. Alright, so here we get, this is 0 to 2 pi, 2 square root of 2 minus 4 square root of 2 over 10. Then integrate with respect to theta. Okay, I'm going to erase this. Okay, we can simplify 2 square root of 2 minus 4 square root of 10. That would be something like 2 minus 1 over 10, 1 over 5. Because 4 over 10 is 2 over 5. 2 over 5, sorry. Okay, 2 minus 2 over 5 is 8 over 5. Okay, so here we have 8 square root of 2, 5. And then we have d theta, 0 to 2 pi. So here we have 8 square root of 2 over 5. Theta from 0 to 2 pi. Oops, let me erase this. Okay, so replacing theta with upper limit 2 pi, then we get 16 square root of 2 pi over 5. So that is the answer for example 6. Okay, Alright, thank you.